In this podcast, I want to show you some additional examples of some concentration units and conversions. So here we see we have a chart, and in the chart it tells us our compound, which is going to be our solute, and then it gives us one of the four concentration values that we work with. Okay, so the first one it gives us molality, and the last one it gives us molality, and then the third one it gives us weight percentage. Okay, so I'm going to help you work through all of these problems so that you understand what's going on. Let's see if I can get my pen. Okay, here's my pen. Alright, let's see. So we're going to start with NAI. I'm going to work these on a separate page, and then we're going to come back and fill in our charts. So if you remember when we first talked about how to do solution concentration conversions between all of the different units that we have, I said you need to make a chart. So here I've made a little chart, solute, solvent, solution, and then we've got our moles and our grams. Okay, so we know that we have molality, and molality is going to be the moles of solute over the kilograms of solvent. So if we have a 0.15 molal solution, that tells us that we have 0.1. Oh, I don't know why my pen's dragging again. It's working and then it starts acting funny again. Alright, 0.15. Okay, and if we have 0.15 moles, that means that our solvent had to be 1 kilogram, which is the same as 1,000 grams. Okay, so we have 1 kilogram, which is 1,000 grams, which is also 1 liter. Okay, liters volumes, not grams, but just so we know. Okay, all right, so now we need to try to get some additional information. So first we can go ahead and get grams of solute. That should be easy enough. So we have 0.15. I'm so sorry, my pen is being a goober tonight. All right, moles. So it looks like I'm just going to be writing in cursive the whole time. All right, and we got 1 mole on bottom. And on top would be the molar mass of NaI, which is 149.89. So we're going to put 149.89. Oh, this pen is driving me nuts. Don't know why it's being a goober. Alright, and then you multiply across, and you get 0.15 times 149.89, which is 22.48. Okay, and that would be grams of our solutes. We're going to put this right here, 22.48. And that's a freaking point right there, since the freaking pen's being retarded. All right, now we can get our moles of our solvent. So we got 1,000 grams. Okay, and this is water. So always assume your solvent's water unless it's otherwise indicated. And then grams on the bottom would be our molar mass of water, which is 18.0158 grams, 1 mole. Okay. All right, and that'll tell us how many moles we have, which is 55.51. Okay, so we're going to go ahead and fill that in our little chart up here. All right, now we just add. So we got 0.15 and 55.51, which is going to give us 55.66. Wow, this pen is being super fun. Hopefully on the next problem it won't look so jacked up. All right, and then 22.48 plus 1,000 is 1,028.48. 22.48. Okay. All right, so now we got our whole chart. We can just go ahead and whop out some conversion factors real quick for all our equations for our units, and we'll be good to go. All right, so we already knew molality. Molarity is going to be your moles of solvent over your liters of, your moles of solute over your liters of solvent. So moles of solute, 0.15, and liters of solvents, 1 liter. Okay, which is 0.15 molar. Okay, so those are molarity. So we can go ahead and go back to our chart and go ahead and fill him in. So we got 0.15. Okay, all right, now weight percentage is going to be your mass of solute over the total mass. So we got 22.48. All right, this is going to be our percentage calc. All right, over our total, which was 1,022.48. And then we've got to multiply by 100. Okay, and that gives us our weight percent of 2.2%. Okay, so we can go back, fill in our 2.2. Okay. All right, and lastly, our mole fraction is going to be our moles of solute over our total moles. All right, which is 0.15 over 55.66. All right, and you don't have to multiply this one by 100, remember. Okay, and that gives us 0.003. Okay, go put that in our chart.